Welcome back, everyone, to another Explainer. Today, we are celebrating a pretty massive milestone. You've officially made it to day 20 of our Python curriculum. Now, over the past few weeks, you've been busy. You've written complex loops, you've structured some really intricate classes, and you've built functioning logic that, actually does stuff. But right now, the game completely changes. Today isn't just about making it work, it's about making it excellent.
Which brings us to the big question. Sure, your code runs, but is it actually ready for review? This is literally the defining question of every professional developer's journey. I mean, writing a script that just functions on your local machine, that's one thing. You hit run, it spits out the right number, and hey, you feel great about it. But transforming that isolated functioning script into a robust, professional, review-ready piece of engineering requires a completely different, highly rigorous mindset. You have to start thinking about the people who will inherit your codebase and all those weird edge cases you haven't even considered yet. So to get there, we are going to tackle a 5-point agenda today. We've got PEP 8 and code style, mastering exception handling, the mutable defaults trap, type hints, and finally, security.
This specific 5-point checklist right here, this is your ultimate barrier to entry. When you submit a pull request, this is the exact mental framework senior engineers are using to evaluate your work. It's not just some arbitrary list. It's a battle-tested gauntlet designed to filter out fragility. If you can confidently check off these 5 items, your code isn't just running, it's thriving, it's scalable, and it is totally ready to be merged into a production environment.
Okay, let's jump right into section 1, PEP 8 and code style, or as I like to call it, the aesthetics of Python. So what exactly is PEP 8? It's the official Python enhancement proposal that lays out the coding conventions and style guidelines for writing clean, readable Python code. Now, don't think of it as a strict, punitive set of handcuffs. Think of it more like the universal dialect of Python. It makes sure that whether you are coding in Tokyo, Toronto, or London, your Python speaks the exact same visual language. And honestly, that uniformity drastically reduces the mental effort it takes to parse through hundreds of lines of logic. Because at the end of the day, code is read much, much more often than it's written. We've all been there, right? You open a file from a colleague, or let's be real, from yourself 6 months ago, and you physically cringe at the chaotic indentation, the messy white space, the completely random naming conventions. It takes you an hour just to figure out what a function does because the variables are literally just named X and Y. Sticking to PEP 8 is absolutely crucial because development is a team sport. Your stylistic choices directly impact your team's cognitive load. Good style isn't just about making things look pretty. Good style is just good manners. Moving right along to section 2, mastering exception handling, which is all about building resilience.
Exception handling is simply the process of responding to and managing unexpected events or errors while a program is running. You see, a true professional doesn't just write code that works under perfectly sterile, lab-like conditions. They actively anticipate the chaos of the real world. They plan for the network randomly dropping mid-download, or a vital config file mysteriously going missing, or a user typing in a massive string of text when your function explicitly asked for an integer. Resilience means your application can take a punch without completely falling apart.
And there is a massive difference between unhandled panic and graceful control. Unhandled exceptions mean sudden, jarring program crashes. We're talking massive, intimidating red error logs thrown right in your end user's face, which just causes confusion and totally destroys trust. Graceful exception handling, on the other hand, uses strategic fallback procedures. It catches those errors in real time and provides clear, actionable feedback to the user, or safely returns the system to a default state. During a code review, we are relentlessly looking for that vital shift from panic to absolute control.
Now for section 3, the mutable defaults trap. This is where we uncover some truly hidden bugs.
So a mutable default is this notorious Python trap where mutable objects, think lists or dictionaries, are used as default argument values in a function definition. And because Python evaluates default arguments when the function is defined, not when it's actually executed, it causes these persistent shared state changes. It is hands down one of the most common pitfalls for a day 20 developer. If you aren't actively hunting for this during your review process, this silent little logic flaw will absolutely wreck your data integrity by blending records together across totally different function calls.
Here is exactly how the trap springs. First, you define a function with an empty list as a default argument. Assuming you'll get a fresh, clean list every single time the function runs. Second, you call that function multiple times in your app. And finally, you watch in absolute horror as the list persists and just keeps growing unexpectedly across all those calls. The data sticks around and piles up because that default list object is only created once in memory when the function is initially defined. Spotting architectural traps exactly like this is the exact reason we do rigorous code reviews.
Okay, let's look at Section 4, Type Hints, and how they help in clarifying your intent.
Type hints give us a formal way to statically indicate the expected type of a value right inside your Python code. Not only does this massively boost readability, but it also enables automated static type checkers like MyPy. You can almost think of type hints as this powerful protective layer of documentation baked right into your variables and function signatures. You aren't just writing logic anymore. You are loudly and permanently communicating exactly what data shapes are supposed to flow through your application. Now, standard dynamic typing is highly flexible. I mean, it's a huge part of why we love Python's rapid development cycle in the first place. But it relies entirely on runtime discovery. That means you might only find out you accidentally passed a dictionary into an integer-based function when the program actually runs in production and causes a massive outage. Type hints, though, represent explicit intent. They catch data type errors before execution during the actual coding process. Adding these annotations during your review prep takes ambiguous inputs and turns them into crystal clear contracts. It'll save you and your team from some seriously maddening silent bugs down the line. Finally, we reach Section 5, Security, the final defense. Security during a code review is the rigorous inspection of source code to find and mitigate potential vulnerabilities, exploits, and unauthorized access points. And we really need to raise the stakes here. Look, bad formatting is annoying. A mutable default bug is frustrating and tricky to track down. But unsecure code is actively dangerous. It threatens your users' privacy, it risks your proprietary data, and honestly, it can single-handedly destroy an organization's entire reputation. Security is the final, non-negotiable step of a code review. I really want to emphasize this powerfully. You absolutely cannot bypass this step. Whether it's checking for SQL injection vulnerabilities in your database queries, making sure API keys and passwords aren't accidentally hard-coded into publicly visible files, or rigorously sanitizing user inputs, this is the ultimate test of your day 20 milestone. Your code can be beautiful, it can be blindingly fast and totally bug-free, but if it is not secure, it is simply not done. Which brings us to our conclusion. What vulnerabilities are hiding in your unreviewed code right now? Seriously, take a moment to think about your current personal projects. I challenge you to open up your development environment right after this explainer finishes and apply these 5 pillars. Check your pep8 styling, fortify your exception handling, hunt down those sneaky mutable defaults, add some comprehensive type hints, and relentlessly lock down your security. Run your very own rigorous Day 20 code review. I guarantee you're going to be surprised at what you find. Happy coding and keep building.